Alice is walking along a road, and it's modeled by the equation y equals 4x. When she reaches a certain point A, she turns right so that she is traveling perpendicular to the original road. So let's draw the original road. If this is our x and y grid, then y equals 4x means you go 1 to the right and 4 up. So we're traveling like this. This is the original road. And then when she gets... when she reaches a certain point, we don't know what it is, at some place on this road, we'll call it A. She turns right, so it means she's turning perpendicular to the original road until she stops at the point 85. So here she is, she's traveling in this direction. A right turn that's perpendicular looks something like this. All right, so Alice is traveling, made a right turn going in the complete opposite direction. Then she stops at 85, 0. So what is this point? So let's see, to figure that out, I'm thinking the Pythagorean theorem could help us at some point because they said it's a right angle here. It's a perpendicular turn. And we know that if this is 85, 0, 85 in the x-axis, then this is 85 for the side length. Do we have anything else? I don't know. Oh, okay, we have the fact that it's perpendicular too. If this is the equation of a line, a perpendicular slope is the opposite sign in the reciprocal. The equation of this line, it has a different y-intercept, but it has a slope of negative 1/4. So how could that help us out? We could find out what b is. Okay, let me make a different color. I know what to do now. We could find out what b is, like I was saying, and then we just need to find out where these two equations cross, the original route that they were taking and the perpendicular route. The blue route has this for an equation, and then the red route, we just need to find out what b is, so we'll plug in a point that's definitely on that line, 0 for y, 85 for x. And then if you solve that equation for b, you're going to get that b is 85 over 4. So we have the full equation. The red equation is y equals negative 1/4 x plus 85 over 4. So in math, if you wanted to find out where two lines cross, you solve them as a system of equations. You plug one line into the other. So y is equal to 4x. I'm going to put that over here. And now if I solve that equation, I'll be finding the x-coordinate for where they cross. And then I think they want the y-coordinate as well because they say the point. Okay, so I plugged in 4x in for y, and when I solve this, that's going to be helping me solve for where these two things cross. Easiest way to solve is to multiply both sides by 4. That will get rid of these denominators. Makes 16x equals negative x plus 85. So I'm going to add an x to both sides, so I get 17x equals 85. Oh, that's too bad. I thought it was going to be an integer, but it's not. It's going to be 85 over 17 for the x-coordinate. And to find the y-coordinate, we just have to plug in 85 over 17 into either equation for x. So if I do that, I get 85 times 4, so that's 340 over 17. Maybe it can be simplified. Let me take a look. Look, I missed something. I could have simplified. Math teacher not simplifying their fraction. 340 divided by 17 is 20. 85 divided by 17, what is that, 5? Yeah, so good lesson. Always simplify your fractions. You can save yourself a lot of work. So we got the point. They cross at 5, 20. The red line, the blue line cross at 5, 20. So that's the answer they're looking for.